everybody. Thank you very much for joining our webinar this afternoon from the University of Reading. My name is Julia Locke. I work in outreach and recruitment at the university, and I'm hosting this webinar with some great academics from the School of the Built Environment at the University of Reading on the very important topic of sustainability through surveying, construction management and architectural engineering. So we've got several speakers today. So I'll quickly pass over to Michael Peters, who,
Okay, lovely. So my name's Michael Peters, Dr. Michael Peters. I'm a lecturer in energy policy in the built environment. I'm also the school director of recruitment and admissions at the School of the Built Environment at the University of Reading. As Julia just mentioned, I have several colleagues with me who are going to present different segments of the webinar. So I will ask each of them to briefly introduce themselves, and we'll begin with Adrian, please.
Good evening, everyone. My name is Adrian Tagg, Chartered Building Surveyor. I'm the lead for building surveying at the University of Reading, and I shall be talking to you about sustainability and the role of the building surveyor. Thank you, Michael.
Thanks, Adrian. Next, we have Apeksha, please.
Thanks, Michael. Hello, good evening, everyone. My name is Apeksha, Program Director for Construction and Surveying Program, and I'll be talking about design for sustainability from the quantity surveying perspective. Thanks, Michael.
Thank you, Apeksha. I'm very pleased to be able to introduce Professor Tabarak Bilal, who will just briefly introduce herself, please.
Good evening, everyone, and welcome to this webinar. My name is Tabarak Bilal. I'm a professor of construction engineering and management, and today I will be talking to you about the profession of construction management and what that means from a sustainability perspective. Thank you very much, Michael.
Thank you, Tabarak. And next, let me move on to the next slide. So the title of this webinar, Building a Sustainable Future Through Surveying, Construction Management and Architectural Engineering. There are 6 bits to it. So first of all, the introduction, where we take a step back and look at the broader context of climate change, the built environment and sustainability, which I will take you through. We'll then go across to Apeksha, who's going to provide a quantity surveying perspective. Then Professor Bilal will give you some fascinating insights in relation to the construction management perspective in this. Hopefully we will then be able to pass across to Dr. Mehdi, who will speak to you about architectural engineering in the context of building a sustainable future. And then finally, from the presentation perspective, building surveying and the important role that that has to play in all of this. And then hopefully we'll have time at the end for a few minutes of Q&A and some discussion. So if you have any questions, keep them in mind, and if you've got a piece of paper and pencil, maybe note them down. Possibly, if you have access to the chat, put them in the chat, and we will come to those questions at the end of everybody presenting. For 200 years, more than 200 years, fossil fuels have been the invisible currency of everyday life. How we live, how we work, how we eat, how we get around, all of those things depend on access to high quality energy sources. And that has predominantly meant a dependency on fossil fuels over the last 200 years plus. So oil, gas, coal. And that has given rise to levels of carbon dioxide in the atmosphere, which are now widely acknowledged to be unsustainable. And you'll be aware of that. Weaning society off carbon dependency is much more than just a technological task. It calls on society to untangle the structures of provision and put in place new, more sustainable infrastructures and forms of social organisation. And governance is key to that endeavour. The reality is, and the picture here is trying to show that governance itself, and by the term governance, I simply mean the mechanisms and processes through which policy is designed and delivered. Governance itself becomes stretched by the demands of climate change and sustainability. It has to reach upwards to the world stage, downwards to the communities, households and regions. Global initiatives must resonate locally and mean something at the local level. Communities must play an important role in the protection of the global commons and in this transition to a more sustainable low carbon future. What we've got in front of us here is a very, very simple schematic that depicts the natural environment in the green rectangle, and within that the oval that you can see, let me just get a highlighter pen, laser pointer. The grey oval, this is everything that we do. All human activity takes place within that grey oval, and then beyond that we have the natural environment. So within the grey oval, the economy. Okay, and this schematic is trying to demonstrate the relationship between the economy and the natural environment. And of course, the built environment resides within the economic activity on planet Earth. So let's just summarize what this shows. So energy and raw materials are extracted from the natural environment, and they are converted into a range of goods and services by producers for the benefit of consumers. During that production phase, there will be an element of residual waste, and some of that will be discharged back to the natural environment through landfill, through incineration. But a proportion of it can be recovered through reuse and recycling, and that goes back then into the production process and is converted into a range of goods and services for the benefit of consumers. In the consumption phase, we again have an element of residual waste. So if you think of, for instance, if you have a takeaway pizza, you eat the pizza, you end up with a cardboard box that is contaminated because it's got lots of oil and stuff from the pizza on it. So you can't really readily recycle the box. So that would end up going back through landfill or incineration into the natural environment. By contrast, a milk bottle that you buy from the supermarket, plastic milk bottle, widely recyclable, and good citizens obviously separate their waste out, and that would end up being recovered through recycling and then used again, once again, by producers. And as I say, construction management is a very important part of what is going on within the economic system. So if we look at the, I need to take the pen. If we look at the left-hand side of this schematic, the production phase, we have extraction of raw materials. Obviously, construction massively relies on extraction of raw materials. It also is a very energy intensive, highly energy intensive sector in making things like steel, cement, very, very energy intensive, and my colleagues will come back to that. We have production processes that can be modified in order to reduce the quantity and the types of raw materials extracted. And there is an element of embodied carbon. So we have direct carbon emissions, that's for instance. That's like when you have your central heating going and you are burning gas, and that is giving rise to atmospheric carbon dioxide emissions. Embodied carbon takes into account the carbon dioxide that was necessary for the creation of particular materials, like, for instance, steel and cement, which are very energy intensive to make. And we also have material intensity. That is, once again, the actual level of emissions that are related to the manufacturing of materials like steel and cement. On the other side, we have waste and supply. So we've got the actual landfilled waste and the incinerated waste. And let's be clear about the role of the construction sector in terms of landfilled waste. So construction, demolition and excavation activities account for approximately 32% of all waste that is landfilled in the United Kingdom per year. The sector generates around 100 million tonnes of waste per year. 90% of that, however, it's important to say this, 90% of that is recovered, but that still leaves you with 5 million tonnes which goes to landfill. So there's lots of scope for improvement there. Then in the middle, we have the interface between producers and consumers, and this includes houses and businesses, and even extends as far as things like product labelling, recycling and so on. There we have regular street. You'll probably be familiar with these Victorian, Georgian houses. In every major UK town and city, you are likely to be able to find a road that looks something like that. And it's the people in the houses that are as important as the structure of the thermal efficiency of the house itself. And this is where we have the interplay, and we start to need to think, if we're talking about sustainability, there's three main parts, aren't there? There's economic factors, social factors, environmental factors, and you can't have an optimal transition to a more sustainable built environment without appreciating and involving people who occupy houses like the ones you see on this slide. Households, why would we be interested? Why would a government be interested? What's the relevance? Well, taking the UK as a case study, homes are responsible for around 27% of direct carbon dioxide emissions. So it's not insignificant. In fact, it's very substantial. And they represent the primary end use sector for natural gas, most of which is used for heating rooms and water heating and gas boilers. Also an interesting thing to note, that adults in Britain spend on average over 90% of their lives indoors. So, you know, if you want bits of evidence to gather together a case for why the built environment is important, it's because currently we have a suboptimal situation with a thermally inefficient housing stock in large parts. Construction is highly energy intensive, as I've already said. The built environment overall, and Apeksha will make reference to this next with some figures, contributes substantially to global carbon dioxide emissions. We've got the waste issue, which I've covered, and that's a persistent challenge. But on the positive side, I don't wish to paint an entirely negative picture. In fact, that's why the things that my colleagues are going to tell you about, I think you will see there are many promising and exciting possibilities for construction contributing substantially and meaningfully towards the transition to a more sustainable low carbon future. So I will now stop sharing my screen and I will invite a pen.
I hope every one of you can see my screen. Okay, thank you very much, Michael. So you now know a bit about built environment, as Michael very rightly explained, and how it is connected to the natural world around us. But I'd like to ask you, think about this question. Have you ever thought about who actually makes sure the buildings stays on budget, stays on schedule, and still respect the environment as well? So the thing is, we don't really see the choices that makes all of this happen, isn't it? And yet, without those careful decisions and the choices, the building would not stand for very long. So someone has to keep an eye on every detail, making sure the plans on paper is actually, turned into a safe, functioning and responsible building in real life. So that's what I'm going to talk about in this quick 10 minutes, the decisions you do not usually see and who is going to make those decisions. So why buildings matter, as Michael made reference to, in recent years, sustainability has become a major focus especially in construction. And this is not some kind of opinion you see on media or some kind of trend. It is exactly based on real facts. So because globally, the built environment accounts for around 40% of global emissions and also a third of carbon emissions. So you may have heard this on news as well. We have now committed to reaching net zero carbon by 2050. Now, what that means is we're trying to balance out all the carbon dioxide and all other greenhouse gas emissions that we emit to the air, so that we are not making the planet warmer over time. Now, we're talking about built environment and construction, aren't we? So what that means for construction is that we need to rethink about how we design and build buildings. Okay, so what is even more interesting is that most of the buildings now, more than half of their lifetime carbon and cost is decided even before construction begins. So by the time construction starts, most of the building's lifetime cost and carbon impact has already been locked. That's a very interesting thing to hear, isn't it? So a quantity survey, in the very short form QS, this is when a QS comes into the scene. So they works at the very early stage when the ideas are still flexible, the choices still matter. You may have heard briefly about the life cycle of a project. So when we talk about early stage, it is the stage that we discussed about the concept, the justification, the strategic need of the project. So that is the stage that the choices still matter, when there's still flexibility and we can, influence the design, influence the cost, and there's less resistance to change and the changes are less costly. So today, the role of a quantity survey is not just about the costing, it is also asking the very important questions. As you can see on the screen, we ask the questions like how much energy will this building use over the next 50 years? How often will materials need to be replaced? How much waste will it create? Is there a smarter option that saves money and reduces harm to the environment? So these are those questions that we ask. Right. Now, when we say we're working in quantity surveying, most people will ask you, so what do you do? Do you count bricks? So I think that's a very fair question, because from the outside, the role can seem a bit technical, measuring, pricing, checking numbers. And yes, of course, we do measure because we are creating cost plans and managing the budget, the cost and the financial side of it. So yes, we do need to measure. But that is just a very small part of the story. We plan and manage and control the budget. We advise on tendering and procurement. We deal with contracts and payments. And every construction is unique, so changes can happen. We treat them as variations and claims and disputes. I know there are a lot of big words here, but I'm pretty sure you have all heard about these words at some point in your life. So identify, analyze, and manage risks and contingencies. So I would say all of this is kind of explains the traditional role of a quantity surveyor, but the role has evolved a lot during the past few years, and quantity surveyors are increasingly become strategic advisors in many different aspects. So design for sustainability is one such aspect that quantity surveyors are providing advice. So QSs can influence the design decisions before they become expensive mistakes. So remember what I said before, changes can be very expensive later in the stage of a project. But if you identify early in the stage, then that is the most ideal stage where we can influence the design and influence the cost with less resistance to change. And that is called design economics. So in the very simplest form, design economics means making those smart and balanced decisions which will end up being projects being practical, sustainable, responsible, and not harming people and planet as well. So when the architects exploring design options, we quantity surveyors are there asking, what does this choice mean over the next 30 to 50 years? Smarter material choices can actually reduce maintenance for decades. And when the designers propose material, quantity surveyors will be asking the question, is this the best long-term value providing option? And how often it will need to be replaced, and what is the carbon impact that comes with it? And when a client wants to move quickly in the project, when they need to expedite the project, we'll be thinking about the procurement strategy. Are they willing to take on the risk that comes with it? Should this be traditional design and build, and what are the risks that comes along with that? Because a better procurement choice can prevent disputes and delays and save a lot of money for the client as well. So these are the conversations that happen long before even construction begins, and they shape everything that follows. So a small design change on paper in the very early stage can save millions over a building's life, and that is why I call it as hidden influence. We don't really see those decisions are made, but it makes a huge impact. So we connect the design ambition with kind of a financial reality check, and we also balance the innovations and digitalization, whether it's done with responsibility. And we look beyond the upfront cost and think about the long-term performance as well. So influence, as I said, is not just about cost control, it's about the sustainability as a whole. So you may have heard already there's three main pillars of sustainability: environmental, economic, and social. So if I start with the economic pillar, if a project is not affordable, it does not get built, or it's not delivering the objective that it promised. So sustainability definitely must work economically as well. And that does not automatically mean that we are thinking about the cheapest options. The cheapest option today may not always be the cheapest for the next 30 to 50 years. So that is where the life cycle thinking that quantity surveyor brings in, whether it's affordable to build initially, whether it's affordable to run, operate, maintain, and end of life as well. And then environmental sustainability, the materials that we choose, the structures that we design, the energy systems we install. So all those design choices will affect the carbon emission for decades. And third, social sustainability, making sure the buildings are supporting the well-being of the people and the quality of the life. So what are those decisions made early in the stage? So I've just given a list of things that a quantity surveyor can influence the design decisions in terms of material selection. We could think about the durability and the lifespan of material. Long-lasting materials reduce the replacement costs. Environmental impact, whether the embodied carbon or recyclability. Structural choices, foundation, roofing, it impacts the longevity and the energy efficiency. And we are looking at the life cycle cost analysis to, produce those decisions. So I've given a quick case study for us to look at. In terms of material selection, external wall. We all know what an external wall is, isn't it? So we have two different options here, option A and B. So as you can see, our first option is a lightweight cladding system. We know what a cladding system is, and then option B is a brick facade system. So if you have a look at the two options, there are pros and cons in both options. Lower initial cost, faster to install, shorter design life, and higher maintenance. In compared to that, option B has higher upfront cost, longer lifespan, but better thermal performance. So what quantity surveys do here is, using life cycle cost analysis, a QS can show the brick facade reduces the heat loss and it lowers the energy bill year after year. And also, as you can see from the table, it lowers the maintenance. So that means the maintenance and the replacement costs can be far lower over the building lifetime. And then embodied carbon is offset by the longer durability and can reduce the operational energy as well. So design for sustainability here means choosing a solution that costs more at the start, but costs less over the next 40 to 60 years. It can produce less waste, support long-term carbon reduction. So we don't just say that this costs more, but what we are saying is this costs more now, but what does it save for over 30 to 60 years? So quantity surveyors, I would like to define as cost engineers. We are not designers and we are not engineers as well, but we do understand a bit of all of it. We connect the design, we connect the engineering and the budget and make sure that everything works together. So why this matter to you? Because you are the generation that will live with the consequences of the decision that we made today. So most of those buildings that we design now will still standing in year 2050. So if you want a career that combines strategic thinking, creativity, and make real world impact by problem solving, and then QS is definitely one for you, because it can influence the key decisions even before they are locked as final. So my final call for action, we now know that quantity surveying is not something we can categorize as counting bricks. We shape budgets, we influence the performance, the sustainability, and I'd like to say that we're more of problem solvers and real world decisions. And it's innovative, and we can become trusted expert advisors in many different ways as well. If you love working with numbers, creativity, strategic thinking, and see your ideas turn into buildings, and quantity surveying is definitely a right career trajectory for you. So thank you very much for listening.
Thank you very much, Apeksha. And now we will hand over to Professor Tabarak for the construction management perspective, please.
So yes, very good, nice introduction to what I am about to tell you in terms of what the profession of construction management entails. So Apeksha has spoken about the early stages in a project life cycle. Construction is actually more or less the last stage before the building is then commissioned and is occupied. So we will look at building for sustainability from a construction management perspective. But I wanted today to explain the career of construction management and who a construction manager is by selecting a case study. One of the most iconic modern buildings in the UK. The Shard embodies the principles of sustainability, but also principles of innovation. So I'm going to mobilize the Shard to explain to you what a construction manager does and how sustainability is informed by this particular career pathway. So the Shard, most probably many of you have seen the Shard or heard of the Shard, is the highest or tallest building in the UK. 310 meters tall, about 95 stories, 72 of which are habitable floors. So the Shard is a mixed-use development offering office space, flats, restaurants, and a 5-star hotel. The construction of the shard started in March 2009, and the project was completed in July 2012. And just to put the height in context, 310 meters, if you compare the height of the shard to the far left with the height of the London Eye, you get a perspective. So the shard is about 2.25 times higher than the London Eye. And then when we consider construction management as a profession, where does construction start? Construction starts after the finish of earlier phases. So there's the costing side of things, the quantity surveying side of things, but even before that, there is the design aspect. So you've got the architects, the creative thinkers who develop visions for buildings. And for the shard in particular, you see the sketches on your left-hand side. These are the sketches of the architect, a world-renowned Italian architect by the name of Renzo Piano. Piano had a vision for a building to be built next to the Thames River in the heart of London. And he wanted a building that resembles a sail, so that you can have the full scale or a feel of a building next to a river. And to put simply, he said that his vision is about creating a simple spire flirting with the weather, knowing that it is the tallest building in the UK and actually in Western Europe as well. But that's where the architect's responsibility kind of finishes, because once the full designs, architectural designs are developed, then these need to be turned into reality, transformed into an actual building, like you see in the picture on the right-hand side. So before I delve deeper into the construction management profession, just a quick comparison between architecture, which I'm sure you know about as a profession. Architects imagine buildings. So Piano imagined the shard. It's about creative design, it's about creating a vision, and it focuses on aesthetics and function. That's what architecture does. Construction management, on the other hand, is delivering that vision. So it makes the vision into a reality, it delivers the building, and basically construction managers build the building. Mostly, they focus on the cost in collaboration with quantity surveyors, of course, the cost of the build, how long the build takes, the quality of the delivered building, also maintaining the safety of the workers in construction sites, but also the public, the general public in and around the site. And of course, sustainability is at the heart of what the construction management profession is about. So focusing on the shard again, I want you to start by looking at the picture on the right-hand side, which is the building itself. And imagine that building is not in place. And look at what is surrounding that site where the shard is standing now. Lots of buildings, you can see the Thames there, lots happening, very busy, very congested. So there are challenges in terms of managing a construction project. The site here is constrained because it's in a bustling part of London, and that poses construction logistical nightmares. Well, just hold on to that thought for the time being. On the left-hand side, you have London Bridge, and I put this picture deliberately because that's where the shard is really. So let's have a look at all of these buildings and the functions, not all of them, some of them, and who are the shard's neighbors. You've got the London Bridge Station Hub, which includes the Network Rail train station, the Tube station, the London bus station, which means that there are thousands of commuters in and around the building site every single day of the week. Not only that, but the main gate to access the site is across the road from Guy's Hospital, one of the leading hospitals in London, and also next to the medical school of King's College London. So again, you're talking about lots of different people passing by the construction site. Below the ground, there is a large Victorian water mains that runs beneath the site, and of course the Jubilee line extensions and the tunneling involved with the tube. So, taking all of that into perspective, what do construction managers do? We don't see construction logistics as nightmares. We see them as dreams. We dream about these drawings. How do we transform these drawings into reality? The Shard was built by one of the largest construction companies in the UK, Mace. And you will see their signs in different towns and places and cities. So what do construction managers do? They lead construction projects. So we have a site. It could be a brown field site, meaning that a building exists that needs to be removed and demolished, or it could be a green site, so pristine piece of land where a project will be built. So they lead construction projects, not just buildings, infrastructure projects, like HS2, for example, or the M25 expansion. I'm trying to give you examples of the iconic kind of projects currently ongoing. They also do manage budgets on construction sites and also the timelines. So, for example, the budget for the Shard, or in fact, the actual total cost, construction cost of the building is £1.5 billion. That's a huge amount of money, but that's the total cost, not just the construction bit of it. It's land acquisition and fees and so on. And as I mentioned before, it took 3 years to build. So all of that is managed by construction managers. They coordinate with other professionals like architects, quantity surveyors, engineers, and they also liaise with external stakeholders. So we know that there's the hospital there, there's the university there, there's a London Bridge station there, and the building itself or the construction process generates a lot of noise and a lot of traffic congestion. And so the construction manager liaises with external stakeholders and communicates with external stakeholders to get their buy-in for the project. Already Michael and Upeksha talked about sustainable construction. I'm going to focus on environmental sustainable construction from a construction management perspective. And this means there is a lot of emphasis on resource efficiency, environmental protection, waste minimization. And there are a number of different principles, environmental sustainability principles relating to construction. For example, reducing resource consumption, reusing materials, protecting nature, recycling materials, and so on. So let's have a look at these principles in the context of the construction of the Shard. Minimization of environmental impact of projects. The Shard was granted or given the BREEAM Excellent award, and that means that it is a very energy efficient building, and it uses efficient energy building systems. For example, it combines heat and power plant. But you can see, you've seen in the previous pictures, the Shard is covered by a facade of glass or glazing to maximize natural lighting, for example, hence lowering energy consumption by the use of artificial lighting. In actual fact, it uses 11,000 glass panels equal to 8 football fields. Uses a lot of intelligent materials as well. Material sustainability, 95% of construction waste was recycled from the demolished building that existed on the site before the Shard was built. 20% of steel used was recycled as well, meaning that there was a reduction in embedded carbon in steel. And you can see the statistics on the left-hand side: 5,500 cubic meters of concrete, 1,000 tons of reinforcement steel used, and that's only in the base, in the foundation, the main foundation system. There are 2 foundation systems in the building. I'm trying to excite you into construction management. So this is the sort of thing that you will learn if you join a construction management program. Efficient use of materials and resources. Off-site prefabrication was used quite extensively in the Shard through the use of precast concrete, for example, and also water and environmental controls. So rainwater harvesting system to feed non-potable water uses like irrigation, toilet flushing, and so on. Light sensors to optimize artificial lighting, and also a built-in wind turbine for generating electricity. However, the Shard is 14 years old, and we're looking into sustainability into the future. Obviously, there are limitations in terms of the context of this particular iconic building because of its age, because of the sheer scale of the building. So it's not a net zero carbon building. It does have high carbon embodied within the materials used. 5,500 cubic meters of concrete for the foundation system alone. That embodies a lot of carbon. And of course, all the high-rise standards compared to modern, more modern buildings is quite a challenge as well. So construction management is about realizing buildings, transforming architectural drawings into actual buildings that we live, we work, and we study in. There are a lot of processes to realize a building, and this is just really a snapshot of what the profession is about. Thank you very much, and I'm going to stop sharing now and reverting back to Michael. Thank you, Michael.
Wonderful, thank you very much indeed. And now swiftly across for the architectural engineering perspective, please, to Dr. Mehdi.
Can you hear me?
Yeah, that's fine. Thank you.
Thank you very much, Michael, for providing me this opportunity, and thanks for providing a brief introduction on the concept of sustainability, and also Apeksha and Tabarek for going through the application of sustainability in design, earlier stage of design, and interesting and important building like Shard. At this stage, I'm mindful of the time. That's why I try to focus on only operational aspect of sustainability and addressing that within the context of architectural engineering program. Before going to the sustainability agenda, I wanted to highlight the existential threat that we are facing. Damaging climate impacts are already being felt today. We already reached 1 degree C increase in the temperature, average surface temperature of the globe over the past many years. And we are very mindful of how we can reduce our global emission faster. And as fast as possible, we reduce our global emission, we can hold warming to lower level. Our aim is not to get to above 1 degree C increase in the global average surface temperature to avoid existential threat and irreversible threat from the climate change and global warming. But what if we reach above 1.5 degrees C average global surface temperature? If we reach above that level, it would be irreversible, and we will face many situations that cause lots of damage and cost us life and resources. Temperature rise is one of the biggest challenges, followed by more extreme weather condition. Many are thinking that, okay, global warming and climate change, the weather in the UK will become like a Spain. It would be pleasant. It would be not as pleasant as you can imagine when we have increase in the ambient temperature. The environment can hold more moisture, and we will have more extreme weather, more flood, more rain, and we will have increase in the sea level because of melting down the ice in North Pole and South Pole. And also we will have lots of acidity in our seas, and that cause the complete change in ecosystem that change the direction of the travel for human being. These are a portfolio of the impact that global warming and increasing the global average surface temperature of the Earth can cause. And how we can avoid it, sustainability is the backbone, the main strategy that we can to avoid the increasing of average surface temperature of the globe. I would like to frame sustainability as a framework that address environmental, social, and economic responsibility that we all have, and net zero carbon targets that we have as a target and mechanism to demonstrate commitment to those responsibilities. Olden days, we had the target for carbon neutral. Advantaged people were using as much as resources that we had and producing as much as emission that they wished to. And our justification those days was to producing the emission, but I offset it by my action, for example, contributing to development of renewable energy sources and so on. Nowadays, it proved that that approach and that strategy wouldn't work if we reach 1.5 degrees C scenario. If we reach 1.5 degrees C scenario, the consequence would be irreversible. And that's why we introduced, over the past couple of years, we introduced the concept of net zero carbon emission in the UK. And UK government is committed to achieve the net zero carbon by 2015. I'm not sure that in the next stage of carbon reduction in my life, I would be able to see, but absolute zero carbon would be the next stage after net zero carbon. In net zero target, we are limiting and capping the emission that we are producing and footprint or carbon footprint to the maximum of emission that reach maximum of 1.5 degrees C scenario. And that amount of emission that is being produced would be offset, but the engagement with generating the renewable energy sources and removing the carbon from the environment. What we can do in operation stage is very important. There are different pathways for achieving net zero carbon emission and achieving sustainability. In architectural engineering program, we learn about those pathways. Pathways like how the demand for travel impact achieving the net zero carbon future. Let's go together and see the current situation. Michael, would you be able to see my screen now? Is it clear now?
Yes, we can see it.
Fantastic. Fantastic. In architectural engineering, we apply the theory of sustainability and agenda for net zero carbon future in practice. And we will be able to quantify the impact of different pathways of achieving net zero in practice. For example, if we reduce the travel demands by 24% of the current travel demands, we can see we can reduce our carbon footprint further to 41% of the original carbon emission that we had in 1990. That's the reference point. The next stage, another pathway that we can explore is how if all the cars, light cars, are become electrified. You can see quickly we can run that scenario and change all the existing light vehicles to electric vehicles and see that we will have further reduction to 45% reduction compared to 1990 level. If we change the heavy vehicles like all bus and train and HGVs to the electric one, how much we can reduce our carbon footprint? We can reduce it down to minus 50% of the original emission. What if we change our behavior, the way that we use energy? For example, if we reduce our temperature set point at home during the winter, when we set the temperature set point, for example, to 20, instead of 20, we reduce it to 80. How much further we can reduce our carbon footprint? Further to 62%. If we put the insulation on our building, how much it impacts achievement of the net zero building agenda? 69%. What if we use the smart thermostats? It will help us to get further down. For example, if we use the smart thermostat and if we use the heat pump technology, we can reduce our carbon footprint further to this level. If for industry, if we go and reduce the carbon footprint in heavy industry, you can see by increasing this bottom, we can see less emission reduced from the industry. We reduce our carbon footprint to 73%. What if for every single person we have 20 square meter of solar panel on top of the buildings? We can reduce our carbon footprint to 84% compared to 1990 level. What we are doing here, one last point that I want to highlight it. What if we introduce nuclear electricity generation instead of using fossil fuel? If we produce more nuclear electricity, like Hinkley C that we are on the process of design and construction of the electricity nuclear power plants. On that case, we can reduce our carbon footprint to 88%. In a nutshell, it is the demonstration of, in architectural engineering, we are thinking about the operational part of the sustainability. We quantify the impact of different pathways, and we learn the theory behind those pathways. And also we learn about the challenges associated with those pathways. For example, when we introduce the heat pump technology here, introducing heat pump technology means shifting the demand for energy from natural gas to electricity. And in parallel with that, we need to provide more sustainable electricity, for example, using wind and solar. And these are the kind of intertwined pathway to achieve net zero carbon future that is embedded in all our program, including architectural engineering, that students learn about the theory and application and challenges associated with application of those theories in practice. That's a kind of overview of what we are learning and talking about sustainability and net zero carbon agenda in architectural engineering in the School of the Built Environment. We are offering architectural engineering in 2 levels, Bachelor of Engineering and Master of Engineering, and a student learn how to evaluate the energy demand and heat profile of different end users, buildings. They learn how to use the digital technology for sustainable construction. They learn how to do the experiment to assessing the impact of different pathway in reducing the carbon emission. And we are supporting our students in different competitions. For example, this is an example of our student taking part in Women in Property with the fantastic project agenda around the sustainability and diversity and inclusion in design stage in the built environments. That was a brief introduction about the operational aspect of sustainability, and I would be more than happy to be available for answering any question at the end of the session. Thank you very much, Michael.
Lovely. Thank you very much, Mehdi. Finally, in terms of the presentation aspect of our webinar, I'm really pleased to be able to invite Adrian to come forward with his slide deck and talk to you about.
Apologies. So yes, thank you everyone for sticking with it. I'm going to go quite quickly and talk about the role of the buildings in terms of sustainability. So we'll talk about the role of what we do. We'll talk about the existing built environment, maintenance of commercial property, then the sustainability challenge, and probably what's most important to you if you're thinking about doing building surveying is the importance of human intelligence. Believe me, we will not be replaced by AI, certainly. Okay, so I'm going to go on to full screen and present. So first of all, of course, building surveying is a kind of one-day visit to a building or over a couple of days to produce a very accurate picture of the building, past, present, and future, to advise our clients upon what we do, advise the clients upon the future, and of course, sustainability is key to that as well. Okay, this is me, of course, on top of a building, so we can do buildings on the roofs, we can do buildings above, go and cherry pick and look at stuff, and we can also go underground to the foundations and inspect buildings for our clients. But essentially, building surveying is to visit buildings, record information and report, and that's why really AI doesn't work for us. Okay, the existing built environment, well, it's everything. It's where we live, we work, we study, we relax, we socialize. It's the physical fabric of society. It's really shaped by the natural environment. You've heard some references to the natural environment. The building and built environment is very shaped by the natural environment. You can see here, you can't really build in this mountainous part of Scotland. It's very hostile climate and snow and stuff, but you can build. You can build in places like Cornwall. And why would we build in Cornwall? Because of the fishing, because of the industry, because of the history. Likewise, you wouldn't necessarily build in the desert, really harsh conditions. You can see how the natural environment shaped the environment. But here we have a map of the UK, and at the very top there, you can see Scotland, very harsh environment. Above that, we've got the granite city, Aberdeen, built on the power of oil. So industry has shaped the way we build things from the natural environment as well. Okay, this is a cotton mill, I think in Yorkshire, and again, very harsh climate to put in, but we can see how the hills and the water has driven the mills in the Victorian era to produce industry and commerce. So the natural environment definitely shapes the built environment, and this again is the final example. It's a hill town, so a town on the hill surrounded by a river, natural defence. So we're always keen to see about the interaction between the natural and built environments. What about commercial property? So, as well as both commercial, this could be built environment, could be houses, it can be modern 3-story houses, it can be mixed-use offices, it can be hotels, pubs, high streets, office buildings, logistics sites, even an old Victorian school there, and that's the school some 7 to 8 years later. Still, not much has changed, and that could be a modern school. There's all examples of the built environment that we as building surveyors work and advise upon. Okay. So when we talk about maintaining commercial property is operated for a business. So it's an investment. It has a real purpose in our economy. Historically, it's always been a very good investment. And in fact, the Royal Institution of Chartered Surveyors, who guide us as surveyors, say that sustainability must be at the heart of what we do when advising on maintenance. They've even produced this rather nice professional standard as to what we should do, including sustainability and how we advise our clients. Going forward, maintenance surveys, yeah, we have to go on the roof, we have to look at the structure, the facades, the finishes, all the services, mechanical and electrical, as well as the external areas, and of course the legal technical. You know, it's a one size fits all, if you like, in the terms of what we do. Is very transferable between the different building types. So if you're advising on the maintenance of this 17th century timber frame Tudor property, you'd have to have the same principles to advising upon this very modern mixed-use development office buildings. So we're quite straightforward and pragmatic building surveyors. We take these guidance and move forward and try and deliver the best possible professional advice. Sustainability is legal technical, so it's a legal requirement with the technical application. So how do we look at that from a perspective of giving advice? Well, the challenge is that all of our work in building surveying is on existing buildings. We build very little new. We're looking at all very much the existing buildings and how we can, adopt energy performance standards and advise clients and reduce our carbon footprint. So, as I said before, carbon is either embodied in what is built, historically in the building or operation. Therefore, we want to retain existing buildings. We don't want to demolish and rebuild. We want to improve the energy efficiency, so improve how they operate in energy efficiency systems. You can see here, this is a concrete facade for a 1970s building. This is what it looks under a heat map. So you can see how much energy that particular building is losing. So the challenge with existing buildings is we have to reduce energy loss and solar gain, reduce energy consumption. Therefore, we could do this by insulating walls, replacing windows, insulating roof spaces, or even adopting low energy insulation like LEDs and seeking alternative sources for heating. But the reality is, how do we do that on a 150-year-old building? This is on the University of Reading campus. How do we do that when the building's listed? How do we do that when it's an old, very important structure? So this is a challenge we have with existing buildings with the advice of a building surveyor. Just kind of coming towards the end and wrapping up, why is human intelligence important? As I said previously, building surveyors have to report to a client based upon recording data on site and visiting a building. So it's evidence-based. So we can only advise them what we say, what we see, what we analyse, very much inquisitive and forensic in our approach to giving client advice. So we have to kind of triangulate the building age, the materials, the defect and symptoms. We have to take ownership, deliver advice, and be responsible. Therefore, human intelligence will always win over artificial intelligence. And accordingly, building services always understand the symbiosis, the kind of cohabitation of the built and natural environments. You can see what was built at Stonehenge all those many years ago. In essence, we're using the same concept of analysing principles of construction and building as we would for this very modern glazed facade building of an office building in the commercial sector. So I've gone very quickly. More than happy to have questions at the end. So I shall stop sharing.
Very much.
Thank
So you've
you.
done amazingly well. Would you like to sum up, Michael?
Well, I think had a whistle-stop tour in miniature of many interconnected but distinctive aspects of surveying and construction, and the way in which they relate to the broader context of addressing the complexities of climate change locally, nationally, internationally, the importance of the different disciplines. They very much work together in the real world, in the construction sector. And you know, when the time comes, if you are interested in pursuing one of the undergraduate programs that we run in the School of the Built Environment, you will see just the extent to which the interconnections between these different aspects of construction and surveying that you've had a taste this evening of work together. And I think we are all passionately believers in the idea that surveying and construction will play a key role in the gradual and hopefully not too gradual transition towards that more sustainable low carbon future. So thank you.